Thomas Bradwardine, a name that might not be as familiar as Galileo or Newton, but one that played a crucial role in bridging medieval thought and early science. This 14th century English scholar was a true polymath, excelling as both a mathematician and a philosopher, and his work laid important foundations for the scientific revolution that would follow. Born around 1290 in Sussex, England, Bradwardine lived during a time of great intellectual ferment. The medieval world was slowly giving way to new ideas, and Bradwardine was at the forefront of this transition. He studied at Oxford University, where he would later become a fellow, and eventually the Archbishop of Canterbury. As a mathematician, Bradwardine made significant contributions that were well ahead of his time. He developed sophisticated theories about the relationship between velocity, force, and resistance, laying the groundwork for later studies in physics. His work on continuous magnitudes and his exploration of infinite series were remarkably advanced for the 14th century, anticipating concepts that would not be fully developed until centuries later. But Bradwardine was more than just a mathematician. He was also a profound philosopher, grappling with complex questions about the nature of God, free will, and predestination. His most famous work, De Causa Dei contra Pelagium, or On the Cause of God against Pelagius, combined rigorous logical argumentation with theological insights, showcasing his ability to bridge different domains of knowledge. What made Bradwardine truly remarkable was his ability to integrate mathematical reasoning with philosophical and theological questions. He used mathematical concepts to explore abstract ideas about infinity and continuity, applying a level of precision to philosophical debates that was uncommon in his time. This approach of using mathematics as a tool for understanding the world would become a cornerstone of the scientific method in later centuries. Bradwardine's work represents a crucial link between medieval scholasticism and the emerging scientific worldview. While he was firmly rooted in the intellectual traditions of his time, his innovative approaches and willingness to challenge established ideas paved the way for the more empirical and mathematical approaches that would characterize the scientific revolution. The influence of Bradwardine's ideas can be traced through subsequent generations of thinkers. His mathematical work on motion and continuity influenced later scientists like Galileo, while his philosophical ideas continued to be debated in academic circles for centuries. Although his name may not be as widely recognized today, his contributions to the development of Western thought are undeniable. Thomas Bradwardine stands as a testament to the power of interdisciplinary thinking. By combining the precision of mathematics with the depth of philosophy, he helped to usher in a new era of intellectual inquiry. His life and work remind us that progress often comes from those who are willing to bridge different fields of knowledge, challenging us to think beyond the boundaries of our own disciplines.